Good morning, my dear students. Welcome to physics class. Before watching this video, please make sure that yesterday's video had been watched. Yesterday's class, I started the topic dimensional analysis. Dimensional analysis. The base quantities are known as the dimensions of physical world, the fundamental quantities. So dimensions of length, L, dimensions of mass, M, dimensions of time, T, and so on. We have discussed. Also, I explained about the dimensional formula for other physical quantities, various physical quantities, derived quantities such as area, L square, volume, L cube, density, M, L power minus 3, and so on. I hope you have understood. I think you have practiced. And I explained about the types also. That is, dimensional variables, dimensionless variables, dimensional constant, dimensionless constant. Dimensional variable, physical quantities which possess dimension but the values can vary. Example, length, velocity, acceleration, mass, etc. Dimensionless variables, variables that is the quantities which do not have dimension, no dimension, and the values can vary. So that is known as dimensionless variables. Example, specific gravity, strain, refractive index, angle, etc. Then dimensional constant. Dimensional constant means physical quantities which possess dimension but have the constant value. Okay, constant value. So examples, gravitational constant, Planck's constant. Dimensionless constant means quantities which have constant value but have no dimension. Example, pi, e, etc. Okay. In continuation with, today we are going to discuss first principle of homogeneity of dimensions. Principle of homogeneity of dimension. Homo means same. Okay. Homogeneity of dimensions. So what it says, principle of homogeneity of dimension states that the dimensions of all the terms in a physical expression should be the same. Principle of homogeneity of dimension states that the dimensions of all the terms in a physical expression should be the same. For example, let me write an expression. One of the equation of motion, v square equal to u square plus 2as. You may have learnt this expression in the equations of motion. V equal to u plus at, s equal to ut plus half at u square, v square equal to u square plus 2as. In that, we are taking this equation. So, principle of homogeneity states that the dimension of v square, the dimension of u square, the dimension of this 2as should be the same. Let us verify that. What is meant by v? V and u are the velocities, isn't it? V is the final velocity, u is the initial velocity. So dimension of v is, velocity dimension is distance divided by time. Displacement is divided by time. So displacement length L, time t power minus 1. This is the dimension of v. That will be also the dimension of u because v and u are the velocity. And 2 has no dimension. It is the dimension less constant number. And a is known as the acceleration. Acceleration means velocity divided by time. So already L t power minus 1, again t power minus 1. So L t power minus 2. Now let us verify this. V square means L t power minus 1 the whole square is equal to u square means again the dimensional formula is L t power minus 1 the whole square plus 2 is 2 does not have any dimension, so we can neglect that. A L t power minus 2 into, what do you mean by S? S is nothing but displacement. So what is the unit of dimension of displacement? L. The dimension of S is L because it is displacement. Now this we can simplify, L square t power minus 2. Isn't it? A power m the whole power n equal to a power m into n. So L square t power minus 1 into 2 minus 2 is equal to L square t power minus 1 into 2 minus 2 plus L into L. L square t power minus 2. Look at this expression. Each term carries the dimensional formula L square t power minus 2. Isn't it? So this equation shows the principle of homogeneity of dimensions. Can you understand? The dimension of V square, dimension of U square, dimension of 2AS are the same and is equal to L square t power minus 1. So this explains the principle of homogeneity of dimension. So it states that the dimensions of all the terms in a physical expression should be the same. Clear? Alright. Now let's move on to uses of dimensional analysis or applications of dimensional analysis. This is an important question, use of dimensional analysis. Previously we have seen the principle of homogeneity of dimension. That also important short answer, okay? Very important short answer. With the example you should learn. And now uses of dimensional analysis or the applications of dimensional analysis. First use is, this method is used to convert a physical quantity from one system of unit to other system of unit. One system of unit to other system of unit. That means if the one system of unit is in CGS, we can convert into SI system of unit. If it is in SI system, we can convert into CGS system of unit. That is the meaning. Second use, this method is used to check the dimensional correctness of the given physical equation. Dimensional correctness of the given physical equation. Previously I explained about the principle of homogeneity of dimension. There we have already done that. That is, each term carries the same dimensional formula. That means that equation is dimensionally correct. That is given here. It is used to check the dimensional correctness of a given physical equation. And the third one is establish the relations among various physical quantities. If there are some various physical quantities, we can able to find the relationship among that quantities with the help of this dimensional analysis. Okay. The uses of dimensional analysis: convert a physical quantity from one system of units to other system, check the dimensional correctness of the given equation, and establish the relations among various physical quantities. Clear? Now let's see each uses with proper explanation and examples. Okay. First use, to convert a physical quantity from one system of units to another system of unit. Actually, this method is based on the formula, that is n of u equal to constant. That means the product of the numerical values and its corresponding unit. Clear? N represents the numerical value, the number, and U represents the unit. So product of numerical value and its corresponding unit is equal to constant. Or else we can write this formula, N1 of U1 is equal to N2 of U2. That is one system of unit and this is the another system of unit. That means suppose consider the physical quantity, a particular physical quantity which has a dimension A in mass. B in length and C in time. Okay. It has the dimension A in mass, small a in mass, and small b in length, and small c in time. A, B, C are the dimensions. If so, the fundamental units in one system we can written as M1, L1, T1. One system we can written as M1, L1, T1. And the other system we can written as M2, L2, T2. M2, L2, T2 respectively. Then we can write according to this formula the product of numerical values in corresponding unit. So N1, M1 power A, L1 power B, T1 power C is equal to N2 into M2 power A, L2 power B, and T2 power C. Clear? So this is the formula we are going to apply the first use. We can write the two system of units in this format: N1, M1 power A, L1 power B, T1 power C equal to N2, M2 power A, B, L2 power B, T2 power C. Okay. So such a way we can convert the numerical value of physical quantity from one unit into other unit. Okay. In this way we can convert the numerical value of one system of units into other system of unit. While doing the problem you can understand. Okay. So anyway they will be asking the problems only for this users and all. Let's see the first problem. Very important problem and frequently asked problem. Example 1.12. Convert 76 centimeter of mercury pressure into Newton meter raised to minus 2 using the method of dimension. Convert 76 centimeter of mercury pressure into Newton meter raised to minus 2 using the method of dimensions. Can you understand? So there is a pressure value 76 centimeter of mercury pressure. So centimeter, so this is in the CGS system. We have to convert this into Newton meter raised to minus 2 means SI system. We have to convert into SI system. You may have understood about the CGS system, SI system, FPS system and all, isn't it? So centimeter means CGS system. That we have to convert into SI system. So we are going to convert CGS system into SI system of unit. Solution. First we should know the numerical value. So for numerical value they have given only this word 76 centimeter of mercury pressure. So what do you mean by this? Actually in CGS system we can say the pressure 76 centimeter of mercury pressure can be written as 76 into 13.6 into 980 9 centimeter raised to minus 2. This is little difficult to understand. I am telling how to understand this equation. Actually the pressure normal formula we know, force per area, isn't it? Here while taking the fluid, liquid or gases, we have to write in terms of a reference level, reference value, that is the mercury pressure, 76 centimeter of mercury pressure. For that we should use the formula H rho G. This is the formula for finding the pressure in the fluid column, where H is the height. The height only it is given as 76 centimeter. Okay. Then 13.6, that is rho value. Rho is nothing but density of mercury. Density of mercury. Okay, that is 13.6 gram per meter cube, centimeter cube. G. G is acceleration due to gravity. That we know, 9.8 meter second raised to minus 2. Since it is a centimeter CGS system, we can write 980. Okay, acceleration due to gravity. Clear? This is the formula for representing the previous value. So 76 centimeter of mercury means we should know it is 76 into 13.6 into 980 dyne centimeter raised to minus 2. This actually comes from the formula P is equal to H rho G, the pressure of a fluid, not solid, gases or liquid. So here we can write H rho G. H is 76 centimeter and rho is, H is a reference, the given value, centimeter value. Rho is density of mercury, the reference density, that is 13.6 gram per centimeter cube, and G is the acceleration due to gravity. I hope you have got an idea. Now let's convert this into SI system. So first we should know the dimensional formula for pressure. With the help of dimensions only we are going to prove. So what is the dimensional formula for pressure? Dimensional formula for pressure. What is it? Previous class we have discussed. For P is M L power minus 1 T power minus 2. This is the dimensional formula. Force per area. Force ml T raised to minus 2. Area is L square. So we can have the formula for pressure is M L power minus 1 T power minus 2. Right. Now let's apply the formula. What is the formula? N1 of U1 equal to N2 of U2. The same method we are going to apply here. We can write P1 of, this P1 is pressure in CGS system. M1 power A, L1 power B, T1 power C is equal to P2 of M2 power A, L2 power B and T2 power C. Okay. Now from this we have to find out the value of P2. Okay. Convert into C. See, this is the SI system. This is the CGS system. So we should know P2. So I can write the P2 value. Just I am writing P2 here. So P2 into M2 power A, L2 power B, T2 power C is equal to P1 into M1 power A, L1 power B, T1 power C. P2 is SI system, P1 is CGS system. So from this, what is P2? P2 is T1 into M1 by M2 the whole power A. Okay. L1 by L2. So P2 is equal to P1 into M1 by M2, L1 by L2, T1 by T2. L1 by L2 the whole power B and T1 by T2 the whole power C. Clear? Now what is A, B, C? That is, as per the dimensional formula, we have to substitute. Because pressure has the dimension 1 in mass, minus 1 in length, minus 2 in time. 1 in mass, minus 1 in length, minus 2 in time. So when we compare this A, B, C with this, we can write A is equal to 1. A is the mass power. B is equal to minus 1. B is the length power. C is equal to minus 2. C is the time power. Okay, T power minus 2. Clear? Right. Now we can substitute this value here. Instead of P1, we have to substitute 76 centimeter of mercury pressure. M1, M2, L1, L2, T1, T2 and all we have to assume with 1 gram, 1 kilogram and all. Let's see. M1, that is all the ones are in CGS system, so we can consider as 1 gram. L1, 1 centimeter. T1, 1 second. Similarly, for SI system, M2 equal to 1 kilogram. Then L2 is equal to 1 meter. T2 is equal to 1 second. So we know the values A, B, C, M1, L1, G1, M2, L2, T2, also P1. Now we can substitute in the previous expression. That is P2. That is the SI system. P2 is equal to P1 into, what is P1? 76 into 13.6 into 980 into M1 by M2. What is M1? 1 gram. 1 gram by 1 kilogram. The whole power. What is power? A. A is equal to 1. Then 1 centimeter by L1 by L2. 1 meter. So L power is minus 1. Then 1 second by 1 second. T1 by T2. The whole power is minus 2. Okay. Now we should simplify this. So when you multiply all these values, 76 into 13.6 into 980, we will be getting 1012928. Check it, okay? Into here, this we have to simplify. That means we have to convert gram into kilogram. Then we can simplify the powers. So what is 1 gram equal to how many kilogram? 10 power minus 3 kilogram. Isn't it? 1 gram is equal to 10 power minus 3 kilogram divided by 1 kilogram, the whole power 1. And 1 centimeter means 10 power minus 2 meter divided by 1 meter, the whole power minus 1. 1 second, the same unit. So don't want to convert under minus 2. Clear? So now we can write 1012928 into kilogram. So 10 power minus 3, the whole power 1. Meter. So 10 power minus 2 into minus 1. Now here 1. So 1 power minus 2. Now we can write 101298 into 10 power minus 3 into 1 minus 3 into minus 2 into minus 1 2. So 1 power minus 2 you can consider as 1. Understand? Now this is the biggest big number, isn't it? So we can write it by means of 1.012928 into 10 power 6. Such a way we can write. Into 10 power minus 3 into 10 power 2. Understand? So this we can write as 1.01292 into 10 power 6. If you are using logarithm, automatically 10 power 6 will come 1.01298. When you multiply ordinarily, we will get like a big number. So this in 10 power 6 means what? 1, 2, 3, 4, 5, 6. So 1012928. Understand? So 1.01298 in 10 power 6. This alone we have written. And in 10 power minus 3 into 10 power 2. So when you simplify this, 1.0129 into 10 power 6 minus 3 plus 2. What is the answer? 6 minus 3 plus 2. 6 plus 2, 8. 8 minus 3, 5. 10 power 5. Understand? So the pressure in the SI system as the numerical value only we can write it as 1.01 into 0129 or 013. Also we can write 1.013 into 10 power 5, and we should write the unit of SI. Unit of SI unit of pressure. What is the SI unit of pressure? Newton meter raised to minus 2. Newton meter raised to minus 2. Are you able to understand this question? Let me revise. So the question is, convert 76 centimeter of mercury into Newton meter raised to minus 2 using the method of dimension. That means this question is in CGS system, we have to convert into SI system. First we should know what is the value of 76 centimeter of mercury pressure. That we have the formula, pressure is equal to H rho G. H is the reference height centimeter, 76 centimeter. Rho is the density of mercury, that is equal to 13.6 grams centimeter raised to minus 3. And G acceleration due to gravity, that is 980 centimeter second raised to minus 2. So we can write the dimensional formula for pressure, that is M L power minus 1 T power minus 2. This already I have explained. Pressure is equal to force per area. There we have to substitute the dimensions of force and area. Then we can use the formula N1 of U1 equal to N2 of U2, that is P CGS system of this value is equal to P1 is considered as CGS system, P2 is considered as SI system, P2 into this value. M1 power A, L1 power B, T1 power C, M2 power A, L2 power B, T2 power C. Now we need P2, so we can write like this, P2 this side and P1 that side. So P2 is equal to P1 into this will go in that side, M1 by M2, L1 by L2, T1 by 2, the whole power ABC. This ABC is nothing but the powers of a dimensional formula of pressure. That is, it has A1 in mass, 1 power in mass, minus 1 in length, minus 2 in time. So A equal to 1, B equal to minus 1 and C equal to minus 2. Next, M1 equal to 1 gram, M2 equal to 1 kilogram, L1 equal to 1 centimeter, L2 equal to 1 meter, T1 equal to 1 second, T2 equal to 1 second. So this set is in CGS system, this set is in SI system. We have to consider. Then we have to substitute these values in the previous formula. 76 in 13.6 in 980. Then 1 gram by 1 kilogram, 1 centimeter by 1 meter, 1 second by 1 second, and the powers. So when you multiply this big number we will get. If we use logarithm, we will be getting directly 1.01292 to the power 6. Otherwise, ordinary multiplication when you are doing, we will get like this. Now, this gram we can write as 10 power minus 3 kilogram. So, 1000 gram equal to 1 kilogram. So, we can write it as 10 power minus 3 kilogram by 1 kilogram. So, kilogram get cancelled. 10 power minus 3 the whole power 1. 10 power minus 3. Then here 1 centimeter we can write as 10 power minus 2 meter. And meter get cancelled. 10 power minus 2 the whole power minus 2. So, 10 power minus 2 into minus 1. 10 power 2. Minus into minus plus. So, 2 into 1 2. And 1 second that is get cancelled. So, we can take it as 1 and simplified form 101292 in 10 power minus 3 in 10 power 2. So this we can write as 1.01292 in 10 power 6 into 10 power minus 3 and 2 into 10 power 2. So when you simplify the 10 powers, you will be getting 10 power 5. This can be written as 1.901292 in 10 power 6. So we can simplify the power 6 minus 3 plus 2 5. So the pressure is converted into SI system as P2 is equal to 1.01 into or 13 in 10 power 5 Newton meter raised to minus 2. I think you have clear about this question, and the next class we can see one more example. Okay students, practice well, note down everything in your physics note and learn. Thank you.